from section 5.2, and it's number 15. So here in this question we're asked to determine an equation in the form of y equals a sine b x minus c plus d. So we're talking about transformations. Now in this class we've talked about these parameters a, b, c, and d already for different kinds of functions. This is the first time we're talking about them for the sine and cosine graphs. So you have to imagine the sine graph is repeating, right? It's a periodic function, so it repeats over and over. So really it could start at various points, right? We're going to try and start the graph as close to the origin as we can. So what I'm going to do is I'm going to just sketch really quickly. So here's 1 pi, here's 2 pi looks like. So this is what a regular sine graph would look like, right? It looked kind of like this. On this scale, the red dotted line is what a regular sine graph would look like. So if you just think about the big picture, this sine graph looks like, okay, it looks like it's been stretched up this way, right? Because it's definitely taller and longer, you know, in the vertical direction. It looks like it hasn't been stretched horizontally though, because if you look at this point, and I'll put my blue marker here, this point right here, and this point right here seems to be the beginning and the end of a full cycle there, right? So it looks like it hasn't been stretched, but it's definitely been moved downward. The midline, so what we would call the midline, the middle of the graph, is definitely lower. So, okay, so let's start to piece together the parameters. So we've got B, we've got C, and we've got D. So what can we tell? Well, you always start from A and work to B, C, and then D. I think that's the easiest. So A, let's see, the amplitude here is not 1 unit, okay? It is definitely from top to bottom. It looks like it's a total of 4 units. So half of that would be 2. So A looks like it should be 2 here, okay? B, now B, remember, was the horizontal stretch or compression. It appears that there is no horizontal stretch or compression. It looks like the beginning to the end is still a 2 pi period, so B appears to be 1. Now C, okay, have we shifted from what a normal sine graph near the origin would start at the origin at 0, 0, 0. Does it look like we've shifted either way? It looks like it starts right at x equals 0 here as well. So it looks like C is, there's no shift at all. So I think we can go with C being 0. Has not really shifted left or right. But the D, definitely it has gone down, right? So we're going to put I think a -1 for D there. All right? So if we put that together now, and if we say to ourselves, okay, I'm just going to simply put these numbers into the equation, we should get something like y equals, A is 2, so we're just going to put 2 there, sine. Now B is 1, so we don't have to put the 1, and C is 0, so we could just put an x there. And then we certainly have to add a -1, or you can just write that as a subtract 1, and there would be your answer for A. Okay? So some hints here. Please make sure that you just start at the left, A, B, and then work towards D. Okay? So figure out the stretches first, if you can. That's probably the easiest way to go, and then work on the shifts left or right and up and down.